Money laundering is a global problem and has far-reaching effects throughout society. It fuels corruption, organised crime and terrorism, as well as environmental crime and modern slavery. It's estimated that 2% to 5% of the world's $100 trillion GDP consists of laundered money, or between $2 and $5 trillion. Yet only 1% of these illegal proceeds, $20 to $50 billion, are ever seized by the authorities. Detecting money laundering patterns is a complex task. Spotting these patterns requires the ability to connect data across firms and borders to identify suspicious networks and dubious flows of funds. However, the problem is that financial institutions, which bear most of the responsibility for detecting suspicious activities, rely on siloed data and systems and are often forbidden from sharing information with other financial institutions. This makes it hard for them to detect these complex money laundering networks and flows. Criminals use sophisticated cross-border layering techniques to hide the origin of the funds. For example, by using money mule networks. Money mules are people who intentionally or unintentionally help criminals launder money by receiving and transferring illegal profits on behalf of someone else. Individually, these transfers may appear legitimate, but when viewed as a whole, patterns emerge to reveal money laundering activities. Let's see how a typical money mule transaction works. A group of criminals make use of multiple mule accounts in country A to receive illegal funds. The funds are transferred to mule accounts in several financial institutions in country B. Finally, the funds are transferred to mule accounts in country C, where they will be withdrawn or moved further. A financial institution in country C might flag one of the transfers as suspicious, but it cannot warn other financial institutions because it may not know where the money has come from and because it's prohibited from sharing the information. But technologies such as privacy-enhancing technologies, machine learning, and network analysis open up new possibilities to improve anti-money laundering efforts, data sharing, and collaborative analytics to detect complex money laundering networks and suspicious flows of funds. Project Aurora has been developed by the BIS Innovation Hub Nordic Centre. The proof of concept tests the feasibility of analysing payments data that is securely protected using privacy-enhancing technologies. Using advanced machine learning to detect complex money laundering techniques across institutions and borders. Project Aurora has 3 parts. In the first part, the project created a synthetic dataset based on recognised patterns of actual domestic and cross-border payments with complex money laundering techniques embedded in the data. In part 2, the project applied different machine learning models to different views of payments data and measured the effectiveness of each in detecting money laundering networks and flows. In part 3, the project utilised different privacy-enhancing technologies on different data sharing and analysis models to securely protect the data, while testing the effectiveness of the machine learning models in detecting money laundering networks and flows. When combining privacy-enhancing technologies, machine learning, and network analysis, the project was able to detect complex money laundering networks that would have gone undetected using siloed analysis and rule-based methods. Analysing networks and behaviours could be more effective in detecting suspicious networks and flows, particularly when including cross-border views of the data. Centralised approaches to data analysis using encryption could be the most effective in detecting more suspicious networks and flows, while decentralised approaches using federated learning could offer new possibilities to collaboratively train machine learning models and share insights without data leaving an institution or borders. Privacy-enhancing technologies could enable the secure and private sharing of data, as well as supporting compliance with privacy rules. And when combined with machine learning, they could be a game-changer in improving anti-money laundering efforts to enable information sharing and collaborative analysis. However, more real-world pilots, run and tested at scale, are required to better understand the practical challenges, and public-private collaboration on this issue is essential. It takes a network to defeat a network. Applying the latest technologies and collaboration could offer new approaches to better combat money laundering, creating a safer and more stable financial system for everyone. Project Aurora, shining a light on dark money.